The moment when a human being can create a working copy of themselves may be far closer than most people are prepared to accept. Not a digital avatar trapped inside a screen, not a voice assistant pretending to understand emotion, but a physical presence that moves, works, and learns in the real world. In late November of 2025, Elon Musk made a statement that quietly stunned even his most loyal followers. He said that within 2 decades, humans may be able to upload their consciousness into a humanoid robot by combining Neuralink with Tesla's Optimus platform. That single sentence reframed everything, not because it sounded like science fiction, but because of who said it when he said it and what Tesla had already built by that point. Imagine waking up one morning to a home that has already been cleaned, organized, and prepared for the day. The dishes are done, the floors are spotless, meals are prepped, laundry is folded. Not because you hired help, and not because you automated a few smart devices, but because a humanoid robot quietly handled everything while you slept. This is not a scene from a movie. It is not a distant fantasy. According to Elon Musk, this future is already under construction. It is being engineered, tested, refined, and prepared for scale inside Tesla facilities right now. At Tesla's shareholder meeting in 2025, Musk made one of the boldest claims of his career. He said that Optimus may become the biggest product ever created, larger than smartphones, larger than automobiles, larger than any consumer technology humanity has ever adopted. What caught many people off guard was not the ambition of the claim, but the confidence behind it. Musk went further, suggesting that Optimus could help eliminate poverty, expand access to health care, and fundamentally redefine human labor. To many listeners, these statements sounded exaggerated, even reckless. But what truly changed the conversation was not the words themselves. It was the robot standing on the stage. Optimus walked freely without support. It navigated space on its own. It danced. It responded to its environment. More importantly, it was already working inside Tesla factories around the clock, performing real tasks instead of rehearsed demonstrations. Yet beneath the headlines and viral clips lies a quieter and far more important truth. Tesla is not building Optimus as a showpiece. It is not being designed as a stunt robot or a research experiment. Optimus is being engineered first and foremost as a homemaker. That single design choice explains nearly everything about why Tesla's humanoid robot looks, moves, and behaves the way it does. Elon Musk is not chasing spectacle. He is chasing usefulness. A robot that can live inside a home must master the most overlooked category of labor in modern society: cooking, cleaning, organizing, caring. These are not glamorous tasks, but they are the foundation of daily life. Most humanoid robots developed over the past decade prioritize speed, agility, or dramatic physical performance. They run, they jump, they flip, they impress, but they fail at the very tasks that matter most inside a human household. Tesla understands that acceptance does not begin in factories or hospitals. It begins in kitchens, living rooms, and bedrooms. If a robot cannot be trusted to safely clean a counter or handle fragile objects, it will never be trusted with anything more serious. That is why Tesla's demonstrations focus on mundane reality rather than theatrical movement. Optimus has already been shown vacuuming floors, wiping surfaces, sorting household items, stirring food, serving meals, and organizing spaces. These are tasks that rarely go viral, yet they represent the true value of domestic automation. Housework does not require acrobatics. It requires patience, precision, and consistency. One of the most difficult challenges Tesla faced in building Optimus was the human hand. Elon Musk has openly admitted that the forearm and hand represent one of the hardest problems in all of robotics. The human hand is an extraordinary biological tool capable of both strength and extreme delicacy. Household work demands a level of dexterity that most robots simply cannot achieve. Folding fabric, holding glass, spreading sauces, slicing food, cleaning surfaces without damage. These actions require continuous micro-adjustments and subtle force control. Tesla approached this problem with a level of seriousness rarely seen in humanoid robotics. Optimus uses hands engineered with dozens of miniature actuators and more than 20 degrees of freedom. Each finger can move independently with precision that approaches human capability. This allows the robot to cradle fragile objects without breaking them and manipulate small items with control rather than brute force. While robots like Boston Dynamics Atlas can perform remarkable feats of balance and athleticism, they still struggle with tasks as simple as peeling fruit or handling delicate kitchen tools. Tesla made a deliberate trade-off. It sacrificed spectacle in favor of fine motor control. For a homemaker robot, that decision changes everything. Equally important is how Optimus learns. Traditional robots rely on rigid programming that breaks down in unpredictable environments. Homes are not controlled spaces. Every household is different. Furniture moves. Objects appear and disappear. Pets and children behave unpredictably. To function in this chaos, Optimus must learn the way humans do. Tesla trains Optimus using a simulation-to-reality learning pipeline. For more than a year, the robot has been training for long daily sessions at Tesla facilities, observing human demonstrations, studying task execution, and practicing in simulated environments before applying those skills in the physical world. Mistakes are not failures. They are data. Each correction improves performance over time. Rather than identifying objects solely by shape, Optimus learns their purpose. It understands that a knife is used for cutting, that a pan is used for cooking, that a container holds ingredients. This functional understanding allows the robot to adapt to new kitchens and unfamiliar layouts without needing detailed pre-programming. Interaction with Optimus is also designed to feel natural. The robot does not rely exclusively on spoken commands. It can interpret gestures, body language, and visual cues. A glance toward a mess or a simple point can communicate intent. This intuitive interaction is powered by Tesla's advanced artificial intelligence systems, which continuously build a three-dimensional understanding of the environment using cameras and real-time processing. Optimus navigates tight hallways, avoids obstacles, recognizes living beings, and adapts instantly when conditions change. This situational awareness is essential in a home where safety and predictability matter more than speed. The upcoming Optimus generation represents Tesla's first commercial humanoid robot. Elon Musk described it as being so realistic that it may feel like a person wearing a robotic suit. The design emphasizes smooth surfaces, hidden joints, and natural movement. This human-like appearance is not cosmetic. It is psychological. A robot that lives in a home must feel familiar, not threatening. Rumored features such as expressive facial displays and advanced voice integration reinforce Tesla's intent to make Optimus a presence that blends into daily life rather than disrupts it. Productivity is where Optimus becomes truly transformative. Musk suggested that the robot could achieve several times the annual productivity of a human because it can operate continuously without fatigue. It does not need sleep. It does not experience burnout. It does not require weekends or holidays. This uninterrupted operation turns domestic labor into a background process. Time once spent on repetitive chores becomes available for creativity, relationships, and rest. Tesla did not build Optimus to impress crowds. It built it to quietly improve daily life. But usefulness alone is not enough. Safety is the next question. A robot inside a home must be trusted completely. It must be predictable, gentle, and fail-safe. Tesla's approach emphasizes vision-based awareness, conservative movement, and continuous learning to reduce risk. Optimus is not designed for aggression or speed. It is designed for coexistence. If Optimus can function safely in one home, that is impressive. But Tesla's real advantage lies in scale. Homemaking is universal. A robot that only a few can afford changes nothing. A robot that can be produced by the millions changes everything. Elon Musk has repeatedly emphasized manufacturability as the key to Optimus. He suggested that once Tesla reaches large-scale production, the cost of each robot could fall to a level comparable to other major household investments. At that point, Optimus transitions from novelty to necessity. Most humanoid robots today cost enormous sums and are built in tiny quantities. Tesla is pursuing the opposite path. Optimus is built using components Tesla has already mastered: batteries, motors, power electronics, artificial intelligence, control software, manufacturing automation. From Musk's perspective, a Tesla vehicle is already a robot. Optimus is simply a robot with arms and legs instead of wheels. This framing explains why Tesla can move so quickly. The company already operates some of the most advanced manufacturing systems in the world. Producing a humanoid robot at scale is not just an engineering challenge. It is a logistics challenge, a supply chain challenge, a quality control challenge. Tesla has spent years solving these problems. Musk has even argued that Tesla is already the largest robot manufacturer in the world, because every vehicle it produces is an autonomous machine. That industrial maturity allows Tesla to approach humanoid robots as consumer products rather than laboratory curiosities. The planned evolution of Optimus follows a familiar pattern. Each generation brings improvements in intelligence, dexterity, endurance, and affordability. This predictable upgrade cycle signals long-term commitment. A household robot must be supported for years, not treated as a disposable experiment. Future versions are expected to operate longer on a single charge, move more efficiently, and perform tasks that demand extreme precision. The difference between fetching an object and carefully pouring a drink without spilling may seem small, but it represents the line between novelty and true domestic utility. Competition in humanoid robotics is growing, particularly from Asia. Several companies are developing impressive hardware and ambitious roadmaps, yet many of these efforts remain hardware-focused. Domestic usefulness requires more than advanced batteries or custom chips. It requires a deeply integrated software ecosystem, continuous learning, and an obsession with safety. Tesla's advantage lies in integration, vision, artificial intelligence, manufacturing, scale. Optimus is not the most athletic robot, it is the most practical one. The real question is not whether Optimus can perform every human task today. It is whether it can improve continuously, scale globally, and integrate safely into everyday life. If it can do that, then the age of household robotics will not arrive gradually. It will arrive all at once. So here is the question for you. Would you trust a humanoid robot to care for your home and your family if it proved itself reliable, affordable, and safe? Share your thoughts in the comments below. This is Teslaris. If you found this exploration valuable, support the channel by liking the video, subscribing, and turning on notifications. Our goal is to reach 1,000 subscribers and build a community focused on understanding the technologies shaping our future. Stay with Teslaris, and we will continue to explore what comes next.